Welcome learners. I welcome you to the session Material Requirement Planning. An inventory manager who wants to do his job in a very efficient manner, he needs the information regarding the usage of a particular item, whether it is a dependent item or an independent item. The item that is having a dependent demand will be varying according to the changes in the sum variable. Say for example, the demand for the new materials and components depend upon the demand of the final product. Independent demand occurs randomly. Distribution inventory has an independent demand. Dependent demand inventories are planned and controlled with the help of material requirement planning and just-in-time techniques. Planning and controlling of independent demand inventories will utilize the EOQ and EBQ analysis. An item is said to exhibit dependent demand characteristics when its use is directly dependent on the scheduled production of a larger component or a parent product of which the item is said to be a part of it. Hence, for example, in a plant manufacturing automobile engines, the demand for the engine block castings is a dependent demand. Once the production schedule for the group of engines is established, the planner knows with certainty that one block will be required for each engine. Conversely, the demand for the cutting oil used by the machines on the line cannot be calculated accurately from the production schedule and bills of materials. Thus, cutting oil is said to have an independent demand. Generally speaking, in an assembly or fabrication type of operations, most production inventory items will have a dependent demand, while maintenance and repair items will have an independent demand. Although the distinction seems to be a relatively simpler one, it is important for an inventory manager to know whether the item exhibits a dependent or an independent demand. Certain inventory control systems function more effectively with one type of item than with the another. We shall see the significance of dependent demand inventory management. If an organization could operate without a dependent demand inventory, it will gladly do so. Every rupee that is tied up in raw materials, supplies and work in progress inventory is a rupee that is taken away from working for the profits. Then why should the organizations have a dependent inventory? The reason for this answer is as follows. It permits the production management system to function. Assemblers must have a component parts to assemble. Manufacturers must have raw materials to convert into component parts and so on. Without some dependent demand inventory, any organization cannot perform the transaction process. It permits the continuous production. The dependent demand permits the continuous production. Inventory can go in for the smooth operations, and it allows the continuous production when short-term demand is inconsistent with the rate of production. An available supply of dependent demand inventory located within the production system permits the workers to keep working during a delay caused by bottlenecks in assembly line systems. Inventory also protects the organization from shortages caused by delayed deliveries with the vendors. This also permits the acquisition cost reduction. Inventory allows an organization to reduce its unit price by taking advantage of the quantity discounts. During inflationary periods, larger purchases can also act as a hedging against the increase in prices. Hence, the dependent demand or the dependent demand inventory is necessary for any organization to have the production management to function and to have a continuous production and for having the cost reduction. The dependent demand inventory systems are the material requirement planning, manufacturing resources planning, and just-in-time systems. We shall discuss one by one. Material requirement planning. This is an integral part of production planning to have an effective inventory control. Production plans are converted into material plans. Material planning techniques can be classified into two main groups: material planning techniques for direct materials, material planning techniques for indirect materials. Material planning techniques for direct materials in turn may be further classified as techniques for high value materials and techniques for the low value materials. Now this materials planning techniques can be grouped like this: direct materials of high value and low value. The main techniques used are bill of materials, material requirement planning, and the inventory control. In case of indirect materials, cost consumption analysis will be the guiding factor, then the exponential smoothing technique and the inventory control. Material requirement planning is a scientific technique of planning for ordering and usage of materials at various levels of production and for monitoring inventories during these activities. MRP is both an inventory control and a scheduling technique. It utilizes the master schedule for the end products, product structure for determining the requirements of sub-assemblies, components and raw materials, procurement or manufacturing lead times, inventory status of the products, and by utilizing the database in a series of steps, it draws up the timings of procurement or manufacture of all the sub-assemblies, parts and raw materials required over the production horizon to meet the given end production schedules. MRP is a technique of working backward from the scheduled quantities and needs and dates for the end items specified in a master production schedule to determine the requirements for components needed to meet a master production schedule. This technique determines what components are needed, how many are needed, when they are needed, when they should be ordered, so that they will be available when needed. This MRP logic serves as a key component in an information system for planning and controlling the production operations and purchasing. The information provided by MRP is highly useful in scheduling because it indicates the relative priorities of shop orders and purchase orders. Materials requirement planning is a technique for determining the quantity and timing for the acquisition of dependent demand items needed to satisfy master production schedule requirements. MRP is also one of the powerful tools that, when applied properly, helps the managers in achieving effective manufacturing control. It is also based on the concept of independent and dependent demand. The demand for the products is considered independent since the orders may not necessarily be related to others in terms of customers and quantity, but only sales requirements are either known or forecast. The quantity of raw materials and components required to make up the products can be calculated depending upon the manufacturing schedule. The dependent demand condition is served by the MRP. This MRP system explodes the finished product requirement schedule into time-phased requirement schedule. The time-phased requirement schedule charts the lead time requirements for the completion of a lot size run of a product. Besides, the MRP processing programs determine the quantities of dependent demand inventory needed for the production each time bucket during the planning horizon. To understand MRP processing system behavior and some of the management planning information provided by the system, we should know about certain MRP terms. We shall now see to the MRP terms now. Gross requirements. This is the total demand for the inventory item per time bucket. For a finished product, the gross requirements come from the master schedule. For all other dependent demand inventory items, the gross requirements are dictated by the parent product's planned order release. Then scheduled receipts. This is the incoming supply of inventory from vendors or other sources. This serves as an accounting information to know the arrival of the inventory. Then available inventory. This is the total inventory available that can be used to satisfy the gross requirements. This inventory includes available inventory carried over a prior period and the addition of scheduled receipts less gross requirements. Net requirements. This is the total amount of inventory that must be obtained in the time period in which it is listed. It is the difference between the gross requirements and the available inventory. Planned ordered receipts. The amount of net requirements inventory we want to satisfy in the time period is planned order receipt. The exact amount of net requirements we choose to satisfy will depend upon the inventory ordering policy. Planned ordered release. The amount of net requirements inventory we want to satisfy adjusted for lead time requirements. This usually will involve pushing the planned order receipts backward in time equal to the lead time for that type of inventory. Requirements explosion. The breaking down or exploding the parent items into component parts that can be individually planned and scheduled. Lead time effect. The supply time or the number of time buckets between the releasing an order and receiving the materials. So we have to know about the gross requirements, scheduled receipts, available inventory, net requirements, planned order receipts, planned order release, requirements explosion and the lead time effect. Now what about the conditions that are required for MRP? MRP is said to be useful only when the following conditions are present. The final product is complex and it is made up of several levels of assemblies which have a common parts and sub-assemblies. The procurement lead times for components and raw materials are relatively long. The manufacturing cycle is long for the finished products. The demand for the products is known and it is desirable to make specific procurement manufacturing plans, especially desirable when products are expensive. So these are all the basic conditions to be satisfied. That is, we must have several levels of assemblies and the lead time of the components and raw materials should be relatively long, manufacturing cycle is long and the demand for the products is known. Then we will pass on to the objectives of MRP. The first and the foremost objective is the inventory reduction. MRP determines how many of a component are needed and when in order to meet the master schedule. MRP enables a manager to procure that component as and when it is needed, thereby avoiding the cost of excessive inventory. Reduction in production and delivery lead time. MRP identifies the materials and components, quantity, timing, availability, production and procurement activities required to meet the delivery deadlines. By coordinating the inventories, procurement and production decisions, MRP helps in avoiding delay in production. It prioritizes production activities by specifying the date for the completion of work on customer job orders. Realistic commitments. Realistic delivery schedules keep the customer satisfied and can enhance the customer satisfaction. By using this MRP, production can give information to the marketing department about likely delivery schedules to prospective customers. Increased efficiency. MRP provides a close coordination among various work centers as products progress through them. Consequently, production can be processed with fewer indirect personnel such as material expeditors and with fewer unplanned interruptions because MRP focuses on having all components available at appropriately scheduled time. The information provided by MRP encourages the production efficiency. The functions served by MRP. Order planning and control. It helps in timing the release of purchase order and also in arriving at the right quantity of materials and components. Priority planning and control. It also helps in studying how the expected dates of availability is compared to the actual date of need for each component. The provision of a basis for planning capacity requirements and developing a broad business plan. So these are all the basic functions that are served by the MRP. Production, order planning and control, priority planning and control, and provision for the planning capacity. Now, while using this MRP method, the following questions are to be answered. What do we want to produce and when? This question can be answered by master production schedule. So, what is to be produced and when is to be produced? This will be explained in master production schedule. What are the components required to make and how many? So, the bill of materials BOM will say about what are the components required to make a final product and how many components are to be purchased. How many are already scheduled to be available in future period? So, the inventory status file will say about the items that are already scheduled. How many more are needed to obtain for each period? The difference between the required quantity and the available quantity will tell about how many units are needed for each period. When to order these components so that they will be available when needed. This will be received or got from the plant order release. So these are all the questions to be raised and these are all the documents from which we can get the answers. Now we shall see about the procedural steps in MRP by knowing about the terms used in MRP. First step is to determine the gross requirements of finished products. The gross requirements is the aggregate quantity taken from three sources: period-wise pending sales orders on hand, period-wise sales forecast, management decision to alter the quantities derived under the period-wise sales, and the period-wise sales forecast on hand and forecasted to smoothen the production. So the gross requirements will be sales orders on hand, forecasted sales orders, and the altering the quantities derived under these two. Determine the net requirements of finished products. The gross requirements obtained will be adjusted by the available inventory of the product to obtain the net requirements. So net requirements will be gross requirements minus the inventory available. Develop a master production schedule. From the net requirements for each time period as determined in the previous step, a master production schedule should be prepared. It is a key to MRP. A master production schedule expresses the overall plan of production and it spells out the different products to be manufactured over a given period of time. Explore the bill of materials and determine the gross requirements. For each assembly, a structured bill of materials is available and it contains the information to identify each item of the assembly and the quantity required per assembly of which it is a part. The gross requirement of each part is ascertained by multiplying the net requirement of the assembly on the master schedule by the quantity required of the part per assembly as given on the bill of materials. Nowadays, this computation is made with the computers on a level-to-level basis. If the part is purchased from outside, the order would be placed and it will conclude the procedure. Of course, purchased quantity is adjusted for the expected loss in the scrap. Screen out the B and C category items which are to be classified under ABC classification. Determine the net requirements of the items. The gross requirements of an item obtained in the previous stages, that is your gross requirements minus the inventory available. So it must be adjusted with the stock on hand and stock on order. Sometimes it may be found that the item is overstocked and does not require to be replenished. At this time, it need to be ordered or manufactured. Adjust the requirement of scrap allowance. Scrap and wastages need to be accounted for during manufacturing so that the exact number will be available for assembly. This is usually done by estimating the percentage of loss and adding it to the net requirement when the item is being ordered. In a computerized MRP system, the percentage of loss is kept in the file so that it may be systematically added when the item is being ordered. It is automatically added when the item is being ordered. Scheduled planning orders. Once the quantity of an item is determined, the next step is to schedule it. While scheduling it, manufacturing cycle time should be considered and the extent the item is offset for the delivery. Explore to the next level. As mentioned in the exploding the bill of materials and the gross requirements, the entire assembly should be exploded at one point of time. But it is done level by level after all the previous steps have been completed. So this is not exploded at one single point of time as discussed in the previous steps. We are going to explode it level by level. Each level of explosion is followed through the steps, namely the screening out the items, determining the requirements, going for the scrap elements. And these steps will be repeated again and again until the entire assembly has been exploded through all the levels and quantities of items are to be determined and the time is freed. Aggregate requirements and determine the order quantities. Some of the items may be common to a number of assemblies and at various levels. It will be therefore wrong to place an order each time an item appears during explosion until the demand is developed after the entire assembly of each product has been exploded, and then the aggregate demand so that one order can be placed. Write and place the planned orders. After the requirements of each item has been determined, their purchase orders and work orders can be taken in the form of computer printouts. And the last step is maintain the schedules. A written order is not an assurance that the product will be delivered on time. So regular follow-up is necessary. Expediting may be required to be done in some of the cases until the product is ready to be delivered to the customer. So these are all the procedural steps. First one is determining the gross requirements, determine the net requirements, develop a master production schedule, explore the bill of materials and determine the gross requirements, then screen out the B and C categories, determine the net requirement of the items, then adjustment for the scrap allowance, scheduled planned orders, explore to the next level, aggregate requirements and determine the order quantities, write and plan the orders and then maintain the schedules. Now we shall see about the assumptions of an MRP program to be a successful one. The basic assumptions underlying for the success of a MRP program. Availability of a suitable computer having adequate capacity. Assembling the line people is used in the manufacture. Up-to-date and accurate bill of materials for all assemblies are available. Existence of a master schedule which is updated and accurate. So these are all the basic assumptions. As an MRP package is offered by the computer software companies, the logical exploring of the future requirements will have an assistance from those companies. The MRP logic is based on the principle of perpetual inventory, wherein net requirement is equal to gross requirement minus the quantity in hand and quantity ordered. So this MRP system will have the following components. It will have master production schedule that will lead to the material requirement planning and processing logic. The inventory status file and the bill of materials will provide the information. Then this MRP will have an order release requirements, orders rescheduling requirements and then planned orders for the future. Master production schedule is a series of time-phased quantities for each item that a company produces, indicating how many are to be produced and when to produce it. Master production schedule is initially developed from customer orders or from forecasts of demand before MRP system begins to operate. The MRP system accepts whatever the master schedule demands and translates FBS end items into specific component requirements. Most items then make a stimulated trial run to determine whether the proposed master schedule can be satisfied. Coming to the inventory status file. Every inventory item being planned must have an inventory status file which gives a complete and updated information on-hand quantities, gross requirements, scheduled receipts and planned order releases for an item. It also includes planning information such as lot sizes, lead times, safety stock levels and scrap allowances. Basically, the job of the inventory status file is to keep the data about the projected use and receipts of each item and to determine the amount of inventory that will be available in each time bucket. If the projected available inventory is not adequate to meet the requirements in a period, the MRP program will recommend that this item is to be ordered. Then bill of materials. To schedule the production of an end product, the MRP system must plan for all the materials, parts and sub-assemblies that go into the end product. The bill of materials file in the computer provides this information. Bill of material file identifies each component by its unique part number and helps processing by a process which will explode the end term requirements into component requirements. The bill of material identifies how much and how each end product is to be manufactured, specifying all subcomponent items, their sequences of build-up, their quantity in each finished product, and the work centers performing the built-up sequences. This information is obtained from the product design documents, workflow analysis, and other standard manufacturing information. The product structure. The primary information to the MRP from bill of materials is the product structure, the levels of components to produce the end product. One unit of product A may require 1 unit of each components of B and C. 1 unit of product B and D may require 1 unit of component of E and 1 from F. So component F in turn requires 1 unit of B and 2 units of C. So to facilitate this MRP processing, each component at every level of BOM must have a unique part number for its identification. The separate identification enables the computer to find any parent item and to determine all the components needed to make it. Determining all the lower level components needed to make a parent is called exploding the requirement by BOM. Now we shall see what are all the prerequisite information system necessary to install an MRP system. Prerequisite information system to install an MRP system. As an inventory management system, MRP can be used to plan inventory needs over a fixed planning horizon. Although MRP can plan inventory requirements for a period of from a single day to several years, the information the program generates is usually based on week intervals. That is, the planning of specific unit production inventory needs will be defined on a weekly inventory usage basis. In MRP terminology, the weeks or any other time periods chosen will be called as time buckets. MRP also seeks to provide useful inventory, production scheduling, and capacity planning information for inventory control purposes. Before MRP system can be installed, certain prerequisite information must be defined. This prerequisite information can include existing customer orders, forecast of demand, rough cut capacity plan, product structure, product design changes, current inventory levels, and planned inventory receipts. We shall see one by one. Existing customer orders. These are customer orders that have been contracted for future delivery and open orders that must be completed in the production period being planned. Forecast of demand. This is a detailed forecast of each product that defines the number of units needed and when they will be required over the planning horizon. Rough cut capacity plan. This optional plan provides general capacity information that can be used to anticipate and correct resource shortages as well as provide the general guidelines necessary to complete master production schedule. Product structure. This information provides a detailed profile of the dependent demand inventory items in the various stages of transformation process. This file of information defines the steps by which dependent demand inventory items come together to create a finished product. Product design changes. This information defines possible changes in inventory requirements caused by product design changes expected during the planning horizon. Current inventory levels defines the existing or available inventory levels at the beginning of the planning horizon. Planned inventory receipts defines the amount of ordered, purchased or contracted inventory items that an organization expects to receive during the planning horizon. The prerequisite information is not only required to install an MRP system, but it may also have to be maintained daily or weekly. The frequency of data input into the MRP system is determined by the type of MRP system an organization chooses. There are two types of MRP system, regenerative system and the net change systems. A regenerative system is a periodic data input system. Under this system, changes in input data are saved until a specific time, such as the end of a week or end of a month. Changes are then run on a group or batch basis. A net change system is a continuous data input system. Under the system, changes are immediately entered into the computer. New MRP planning information is then recomputed for all components in the inventory system that are affected by the changes. Now we shall see what are all the information outputs an MRP system requires. The output of MRP system includes the 5 types of information: schedule of planned order releases, authorized order releases, change reports, control reports and planning reports. A schedule of planned order releases is a detailed printout defining the amount of inventory required in a specific time bucket. The printout includes information for all orders and inventory requirements over the designated planning horizon. The information is usually presented in a fairly simple reports that list the inventory item by name and number and define the time-phased quantities by time bucket over a planning horizon. Authorized order releases or short-term order releases. They authorize the department such as the purchasing to acquire a specific amount of inventory for use in a specific period. Change reports are initiated by an MRP system even when planned orders cannot be achieved in the time and quantity originally stated in the master schedule. The change reports can include revisions to order due dates, order quantities, orders that need to be delayed or suspended, orders that will be expedited, and orders that can be cancelled. Control reports are generated by MRP system in the form of statistics on inventory level status. The reports include information such as averages and tallies of orders that will not arrive on due dates, stockouts and inventory cost information. A special type of control report is an exception report, a report used to signal discrepancies in time items such as excessive scrap rates and order delivery dates and to convey other reporting errors. For example, the MRP system will generate an exception report when data are entered that do not make sense to the computer. Planning report can include many different types of information on inventory requirements. Planning reports might examine the cost of inventory, purchase trends, capacity planning or safety stock levels. So the information outputs of MRP system include schedule of planned order releases, authorized order releases, change reports, control reports and planning reports. Now we shall see the merits and demerits of MRP system. The merits. It is the detailed means of controlling the inventory items on a current basis. It also improves the production scheduling because the system sets deadlines on material arrivals and also the activities of production. It reduces all types of inventory levels because the timing of materials minimizes the need for safety and buffer stocks. It also helps in capacity building. It provides a way to examine the different inventory ordering policies by stimulating their possible impact on the operations management system. So the MRP normally helps in controlling the inventory, improving the production scheduling, reducing the inventory levels, and helps in the capacity planning. The demerits of MRP system are as follows. Planning and implementation time for MRP systems may take time, that is, it may also go for years. Data entry requirements and file maintenance are very time-consuming process and require substantial personnel training and education. Dependence of the entire system on forecast and estimated lead time can make the informational value of MRP output questionable one and can even mislead the managers on the actual capability of the operations management system. Although microcomputer system exists to support the small production operations, in practice an MRP system requires the costly computer time of a larger scale or a mainframe computer system. For many organizations, the advantages of using MRP system may overweigh the disadvantages. So it is popularly followed in many organizations combined with the other technologies. The use of barcodes on inventory items and optical scanning equipment as an input into the computer system have proved to be successful. Next comes the manufacturing resource planning, MRP2. It is an integrated information system that synchronizes all aspects of business. Manufacturing resource planning coordinates sales, purchasing, manufacturing, finance and engineering by adopting a focal production plan and by using one unified database to plan and update the activities in all systems. A manufacturing resource planning can be divided into three parts. Production planning functions which take place at the top management level, operational planning handled by the staff units, operational control functions conducted by the manufacturing line and staff supervisors. So it includes production planning, operations planning and operations control. Checkpoints among the three divisions provide feedback regarding the adequacy of overall resources, completeness of resource commitments and the quality of performance in carrying out the plans. Feedback based on these checks permits a quick response to changing conditions using the latest operating data. MRP2 integrated system for planning and control involves developing a production plan from the business plan to specify many levels of production for each of the product line over the next 5 years or a decade. The production department is then expected to produce the committed levels, the sales department to sell at these levels, and the finance department to ensure the adequacy of financial resources for these levels. Then the production plan guides the master schedule and gives the weekly quantities of specific products to be built. Then the capacity available is thoroughly adequate. If not, either the master schedule or the capacity is changed. Once settled, this master schedule is used in MRP to create the materials requirement and priority schedules for production. Then an analysis of detailed capacity requirement determines whether capacity is sufficient at each work center during scheduled time periods. Then the execution and control activities are determined to ensure that the master schedule is met. The next is the just-in-time system. The just-in-time inventory control system is originally developed in Japan, and it implies that the firm should maintain a minimum level of inventory and rely on suppliers to provide parts and components just in time to meet its assembly requirements. This may be contrasted with the traditional inventory management system, which calls for maintaining a healthy level of safety stock to provide a reasonable protection against uncertainties of consumption and supply. The traditional Western manufacturing system may be referred to as just-in-case system. The term just-in-case was originally used in a light-hearted way by commentators but become more seriously used, especially in their theory aspects. It refers to the preoccupation of the manufacturers with inventory. Literally, the term suggests a system in which products are made just in case they are needed. It serves as a useful purpose in highlighting the anomalies of the traditional Western manufacturing systems. The just-in-time inventory system, while conceptually very appealing, is very difficult to implement because it involves significant change in the total production and management system. It requires, inter alia, a strong and a dependable relationship with the suppliers who are geographically not far off from the manufacturing facility, a reliable support system, and an easy physical access in the form of adequate doors and conveniently located docks and storage areas to dovetail the incoming materials to the needs of the assembly line. Under the just-in-inventory system, a concerted effort is made to lower the ordering cost and also the safety stock by forging a stronger relationship with the supplier. As a result, both the components decline, and this means that average inventory level is lower. The success of the Japanese companies in cutting manufacturing costs is attributed in part to the use of just-in-time inventory method. The practice of having inputs to the production process delivered precisely when they are needed, thereby assigning the suppliers the responsibility for keeping inventories to the minimum. The use of this method can even result in zero inventory, but zero inventory is seen to be unrealistic. Nevertheless, JIT can reduce inventory considerably and it can result in a high profitability. Thus, these are the inventory control techniques that has to be followed in an organization. By having the control over the inventory, any manufacturing organization can lower the levels of inventory, decrease the carrying cost and the ordering cost, and get a maximum benefit by having the control over the cost of carrying the stock and not carrying the stock. Thank you.